please take your seats on the stage. Professor Ishihara. Ladies and gentlemen, good morning. It is a great privilege and honor to chair this session, the Momentous session, devoted to the geotechnical engineering for the next millennium. I shall be very short on presentation in order to save time and because obviously all people on the stage are extremely well known to all of you. Professor Victor de Mello is a person so well known to all of you that any presentation of his CV appears highly inappropriate in relation to the stature of the person. Let me allow only to mention that as a researcher, as practicing engineer, and when he was the president of our international society, Professor de Mello gave the milestone and inestimable contribution to the worldwide recognition of our discipline and to the consolidation of the international geotechnical community, the International Society for Soil Mechanics and Foundation Engineering. I had the fortune and privilege to meet Professor de Mello more than 30 years ago. I should be not more precise on this point. Since then, our relation has been transformed in long-lasting friendship. A continuous interaction with Professor de Mello through years has allowed me to appreciate fully his wisdom and brilliant intelligence. And in the meantime, our friendship permit me also to learn a lot from him, both in the field of engineering as well as many aspects of human life are concerned. Further on my left is Professor Kenji Ishihara, also extremely well known to all of us. He is the current president of our International Society for Soil Mechanics and Foundation and Geotechnical Engineering for the period 1997-2001. Therefore, he will bring our society to the next millennium. Till a few months, he was the president of the Japanese Geotechnical Society. In the period 1989-1993, Professor Ishihara was the vice president of the International Society for Asian region. He was appointed in last few years as ranking lecturer and as Terzaghi orator in Hamburg during last international conference. Professor Kenji Ishihara is the founder and promoter of the earthquake geotechnical engineering and world-leading expert on soil dynamics, liquefaction phenomena, soil improvement, and foundation design in seismic area. I shall add small personal remark. Despite he is heavily loaded by the work and traveling for the International Society, he is continuously publishing very valuable paper and is continuing his extremely important work as the researcher in geotechnical engineering. On my right, we have Professor Francis Bogosian. He is the president of this conference, vice president and long-life member of the Brazilian Society for Soil Mechanics and Geotechnical Engineering, president of Geomechanica, private geotechnical enterprise, a dean and professor of soil mechanics and foundation engineering at the private university UVA, president of Enterprise Association for Civil Engineering in Rio de Janeiro, and obviously the current president of the International Society for South America. Further on my right, Dr. Guillermo Springall, currently for a period 1997-2001, Vice President for North America of the International Society for Soil Mechanics and Geotechnical Engineering. Since 1965, Director General of well-known geotechnical consulting in Mexico, Geotech. For more than 20 years, he was Professor of Soil Mechanics and Foundation Engineering at the National Autonomous University of Mexico City, teaching graduate and postgraduate program. He was the President of Mexican Society for Soil Mechanics, and in last 20 years, he's acting really as a foreign minister of the Mexican National Society for Soil Mechanics, being a delegate for all international events and venue. This is the short presentation of very knowledgeable and very well-known people on the stage, and now I am inviting Professor Victor de Mello to bring us all together to the next millennium.
Well, Mr. President, thank you very much. Thank you to the organizing committee for this momentous occasion in which we will be going into the new millennium together. Past president, present president, and all future presidents that are potentially here. So it's not going to be a momentous occasion, but hopefully momentary hope for everybody. Thank you very much. And it is really a great privilege and honor. I take the liberty to tell you that I like to address your faces. And if you smile, I'll be happy. If you frown, I'll be unhappy. But that's part of life. Some of you may have had the experience of trying to be Forsyth-Saga in comparison with all the treatments that are proposed. Just assume that you're putting in, and incidentally, different costs were used 3 times or 10 times and so on for the recompaction in comparison with first-time compaction. And still, all of these tendencies, the risk to failure versus total cost, none of the treatments gave the guide. Incidentally, many people, they abandoned more than 50% of the specialists in 1989. Of course, by now, 1999, all of them would agree that they know everything. Will we ever reach this status of knowing everything? To our clients, yes. To ourselves, no. Don't you look at yourself in the mirror every morning and say, what do I really know? So, next trial, at about the same time, braced excavations, questions, pressures on the seating. There were 2 responses of strut loads and horizontal movements on the sheeting. There are no response from the 5 learned predictors on horizontal and vertical movements at a distant point P, which I'm showing in a drawing. And a question, what would be the pore pressure diagram along the vertical at that distant point? Ask any professional, not only in 1970, but today. Please tell me how much is going to be the pore pressure profile along that vertical in the clay about 60 degrees away. Nobody has ever done that. How can you get a reasonable guess? Well, so the results were completely and absurdly different, one from another, and compared with calculated from the data observed. Note, nobody discussed the question of whether the data was valid, interpreted profile or not. Nobody discusses the quality of samples, how much a given parameter is really valid or not, etc. And, of course, the net excuse is always that, well, there was not enough data, or the data must have been somewhat bad a posteriori. And the panel said, for such a situation, the Earth stress theories are less important than a reliable prediction of the distribution of pore water pressure. So we hand ourselves over to hydraulics. Listen, the only pressure that really matters is the pressure of water. So the K naught, Ka, Kp, and this and that, and so on and so forth. Now, as a sequence to that paper, some of the recommendations by Terzaghi Peck and so on are mentioned here. They were changed somewhat, but continued with the same problems. But let me show you the drawing to give you an impression of how the responses were entirely variable. I show here the different responses. Nature's variation is much smaller. Nature does have a dispersion, but it is we, on testing, on interpretation, on methods and so on, that introduce much wider dispersions. So here's the nature's smaller dispersion and the various answers. Here I'm giving an average and the standard deviations. Well, the standard deviations give us an impression on the variability of the replies. Well, here's the point I mentioned to you, along which one of the questions was, with great intellectual curiosity. Incidentally, I'm not against intellectual curiosity, but I am here for discussing things with colleague professionals who have to answer to society for what they do. I think there's a place for both. Now, what is the expected U along this vertical when the braced excavation is here? So I'm saying, has anybody done that? I'm sure that if I ask you to raise your hand, nobody will. Well, so let's continue with some other. Very quick. Here's up to 1982. Pile driving in a condition where the Low Countries, Netherlands, Belgium, and so on, have driven millions of piles. So there were 37 volunteer predictors, 11 from Holland, 16 from Europe, 10 from the world. We have the privilege of having among us Lucella de Cruz, one of the great predictors, who hit on the bullseye and got the prize. Well, here's the profile. And what were the predictions sought? Penetrability, ultimate load, and the curve of settlement versus. Now, I take the liberty to mention that one of the great misleadings of these prediction versus performance things is expecting a deterministic answer, expecting that we should give a bullseye reply. So here was the final curve, test pile, and these were the various answers. And of course, I got some results at factors of safety of 1.5, 2, and 3, and so on in the next drawing. What were the explanations a posteriori? Well, that the test pile was widely different because of a faulty hammer. The winner, I take the liberty to mention that's perfect coincidence of result, using very simple correlation, SPT. The predictor in performance with widely different load test procedures. The load test procedure that was used in this test was not the load test procedure that most people use normally. So then again, when you mix academic interests and enthusiasm, very worthwhile. But when you mix them with practical experience, you have to use the same test. No, you make special tests, go back, unloading, reloading, cycling, and so on, and then by coincidence you get the same result. Well, I'm sorry, but that is not really fair. It is not fair. It's not fair to ask a good basketball player to go to the football field. Now, here some typical histograms of the ultimate load capacities that were that were estimated by these 37 volunteers from all over the world. And to go a little bit more quickly, because I know my time is always short, I wish God will think of that when he decides to call me. Anyhow, so here my calculations on factors of safety, 3, 2, 1.5. We work with factors of safety on the ultimate load. So we want to find out how is it going to behave at factors of safety. Everybody mentions 2 or 3 as typical factors of safety for piles. Now, you see the tremendous scatter, but a great number of people, and incidentally in the next drawing I'll show that these are the people from, specifically from Belgium and Holland and so on. They estimated fairly well, not too far. Why? Because the piles are driven and they have that, people talk about the residual driving stress. It's not really stress, it's the equivalent deformation that you have by precompression of the pile stress under driving. Now, Professor Begeman, a very dear friend, incidentally, before we continue, I must say that I follow very carefully these 2 or 3 learnings of my childhood and criticize the facts, not the people. I mentioned this. We are here, fortunately, because people like them, our mentors, gave their first estimates to help us. Now, the problem is whether or not we exaggerate and put those suggestions on an altar. That is our fault, not theirs. So if I criticize some of these things, you bear that in mind. It's not the persons. I respect and admire and have great affection for them. There were 13 local predictors numbered here whose estimates of internal friction by CPT methods and undrained shear strength by CPT methods, that is indirect information. Bergman suggested by using ratios between point load and friction load that you could avoid having to fill a sample. Somehow they're forgetting that it took mankind millions of years to develop a visual neurological capacity interpretative that's supposed to occupy more than 90% of our brain. So when you feel, you are not only thinking in terms of phi dash and SU and so on, you're getting an awful lot more, I hope, information. And if you avoid that, if you really say, no, all I can do is use these formulas and so on and so forth, you are really demeaning one of mankind's greatest capacities of survival that nature gave us. The fact is that you get this tremendous variation of estimates, maximum 170, minimum 15, by local predictors, maximum 46 degrees and 24 degrees at the same stratum. We are within the family. If I were to present this talk in the Institution of Engineers, I wouldn't do it at all. I would try to transmit. A doctor, among other things, has to give the client the feeling that he knows, because otherwise more than 50% of the healing activity disappears. If the client feels insecure about the doctor, well, unfortunately, the remedy obviously is going to be much less productive than imagined. Well, here was another case. Again, tremendous costs oriented by academic interests, SPTs of very questionable quality. That's different because that's the United States. Filled veins, CPTU, undisturbed tube samples. Nobody gives the details of how the tube samples were, whether they're fixed piston or not, and so on and so forth. All these actual tests and so on without discussing quality. Then the questions, actual, final thing. Then the information at the end of 2, 5, and 43 weeks, what would be the time set? How many professional problems do we concern ourselves with how much improvement is going to be in the end of 1 year? That is part of God's granted privilege. We know what we deal with in civil engineering and geotechnical engineering is maxima and minima. If I guarantee a certain value, from then on it only improves, all the better. But to estimate exactly how much, very difficult. Well, anyhow, so these were some of the questions. Poor pressure responses in this material. Now, pipe pile, cased pile, slurry pile, how many pipe piles are driven with a plate wider than the pipe? How many cases of piles are done in this manner? And so on. Net result is shocking. That obviously the average dispersion and so on, very good. That is, always we find that the group as such has a sort of reasonable feel. You think so much, I think so much. Well, in the end, let's settle on that, compromise. But a client is not going to hire all of us as consultants. So some of these are very interesting. The pipe pile gave about the best around the prediction one pipe pile, because in that area the predictors had the greatest experience with pipe piles. And then of course they always say no net conclusion for the profession or for academia, because unfortunately the dispersions were much too big and there was no conclusion as to what theory should be used. Well, moving on to another case, 5 spread footings on pure sands and spread footings on pure sands. For heaven's sakes, it's the simplest of materials that presumably all of us know everything about. So, to begin with, D'Apollonia and MIT and so on, back in 1968, made a very interesting analysis. Then I will mention the Briot and Gibbons challenge, which is the principal one I'm going to detail on. And then, just to give you an idea of how you can reinterpret, I reinterpreted Burbridge's data and all previous data by a publication by Santa Maria and so on, 1994. Now, I will give quickly some of this information. Well, to begin with, the D'Apollonia's data was on a building on which they had a great number of footings settling in different, they had to predict the settlements for the sands. So they have plate tests, they have real 500 footings or so of different sizes. Now, one of the things that we forget is that when we discuss real buildings, we don't really know the real loads. They are all nominal loads. And our structural friends know the loads so well, they have a special connection with God, that every time we ask them, what are the loads? Oh, 219.33 tons. Well, how did you get that? Computer gave it to me. Okay. So we cannot improve our knowledge in service to structures unless they also interact with us. And when do we ask for that? I was recently very happy to see that Van Wely, for instance, put his entire building on top of load cells and is able to record loads of people coming in and going out for work and reacting with load tests against the structure, finding out that all 55 footing columns change and so on, that sort of thing. Well, it takes a little bit of interaction with the structuralists. But anyhow, the fact is that these were the real estimates, and here were the Zaginpek and so on recommendations how they should work with respect to the footing settlements. It was very poor, but next came the thought, well, let's do a real load test. And these load tests were also again done under, unfortunately, restrictive conditions. Load it until 150 millimeters. But we know that 150 millimeters is essentially failure load for a certain size and is far from failure load for other sizes. So why do you stop, due to a standard that imposes a maximum 150 millimeters settlement, why do you stop trying to gain the knowledge, even in a predictive case? Well, then the questions were predict failure rate pressure, this defined as sigma for 150 millimeters. The poor sand doesn't know that it has to give a sort of a special alarm when it gets to 150 millimeters. It tries to behave the way it should, that's all. And we don't want to know that. Then, secondly, try to estimate the creep for 20 years. Now, the creep for 20 years was based on the fact that at some points here, during the load test, they measured the movement from 1 to 30 millimeters, and by some special tablet of Moses, it was decided that the first 1 minute would be pseudo-elastic movement, and from 1 to 30 minutes, pseudo-creep. And therefore, these 30 minutes were supposed to be extrapolated as a creep equation for 20 years. Now, if you extrapolate from 30 to 20 years, it means you're trying to extrapolate from 30 to 10.5 times 10 to the 6. I think they need Nostradamus at that point. Really. I mean, some of these questions, why don't we get together and really criticize each other jokingly before it is done? Well, I mean, it's impossible. You measure the dew at night and you calculate the PMF. That is a million times. So, let's see what the results were. Of course, just to show you good predictions, plus or minus 20% and so on, very small percentage. There were predictions that went up to ratios, factors of safety of 9.7, and there were two predictions of 4.8. So in other words, two persons, very learned, concluded that there would be failure. And the average factor of safety was 5.4. Our situation of lack of knowledge, real knowledge, leads to this fact that we over-design greatest percentage of our jobs. And by over-designing, of course, we are not helping the development of developing nations. Now, nature's variation is much less. The two footings of 3 meters gave a variation of plus or minus 7% only. And among the academic people, they got to the level of calculating different results for the 2 3-meter footings, merely because they had slightly different SPTs and CPTs. I don't think any professional does that. When we decide to do a design, we generally decide on a certain allowable sigma and design the entire building for that. For small footings, be careful about failure. For big footings, be careful about settlement. And that's all. And then everybody is satisfied. Well, anyhow, the statistical reanalysis for footings on sands and trying to find some more interesting results. It's over the past 10, 15 years we've known, especially some of the very careful work done by my dear friend Zamikowski and others and so on, the conference in Firenze, small strain modular elasticity being very much higher than large strain. Instead of talking in terms of strain, I transform that in factors of safety and so on, this curve. And so you have great variations of strain, of modular elasticity with strains. And I used the Plantemma pile extrapolation, Plantemma's equation, in order to extrapolate when the data was not available. And what results do we get? Well, I reanalyzed the Burbidge Imperial College data. Now, here is the effect of breadth versus pressure. You see Aquarius and all the galaxies put together, the Milky Way, and so on and so forth. Now, it's very simple. So, well, here is going to be dense, medium, loose, and so on, by decision. Tablets from Mount Sinai, you do that. And here, again, the second question, the creep. Time in days versus rate of creep, and another galaxy, and then you decide. Thanks to those who decide, because they help the great mass. But for us who are trying to advance somewhat, we should try to analyze statistically. And trying to analyze statistically, if you separate the data of very loose, general, the general equation, of course, is very poor, medium dense, very dense, and so on, you find that you get fairly good regressions and essentially capable of being separated. Another question that I want to ask is the following. Why is it in the computer age, where any computer gives any number of statistical regressions that you might like, why is it that we never give statistical regressions? And when we do, in 200 cases give the R square or the dispersions. Now, unless you have the dispersions, you don't know how to act, because we have to decide on the basis of maxima and minima. So by dispersion. And how do we improve the profession? By trying to improve the average, but principally by trying to tighten the dispersion. That's how the profession can be improved. Well, here is an attempt to have done that, and you see that if I separate by factors of safety, then you find very interesting regressions with R squared values, pretty good. The same data, I didn't have anything to do. As a matter of fact, that's one of the policies I've always followed. When you want to discuss something with the Northern Hemisphere, they are up on the top now. I have a friend in Porto Alegre who used to have the globe turned the other way around. He said, we like to have the Southern Hemisphere on top. Incidentally, in the first maps, about 1,000 years ago, the Southern Hemisphere was on top. So he says, well, but nowadays, the Northern Hemisphere is always on top. So when you want to discuss with somebody from the Northern Hemisphere, use his data. Because otherwise he says, well, this data, I don't believe it. It's badly done and so on. So I use his data. Now, conclusions. Present shocking number of methods. 31 predictors use 20 different methods. And conservative, very erratic results. Now, if you distinguish the tests by codes of ignorance for safety practice and the tests for behavior research, we have to have codes before we know everything, because we will never know everything. But the code should be more or less nothing more than a suggestion, a reference code, and if you want to do research, go ahead. What's to stop you from pushing the road test to 20, 30, 40 centimeters? What's the problem? It's just a question of trying to follow a code, and it's very sad. Now, when I talk about 20 different methods by 31 predictors, I would like to ask you to compare with our colleagues. You ask reinforced concrete designers, how many methods do they use to compute reinforced concrete? You ask hydraulic engineers to settle on calculations for hydraulics, how many methods do they use? One. So it is really shocking to us that we not only develop, but we maintain and promote 20, 22, 25 different methods, every time more and more methods, and never go back and reanalyze statistically to see what have I really improved. I have improved my dignity as another author of another paper, or have I improved the profession? Well, there are some criticism that I've very frequently made. For instance, my very dear friend, Björn. So he established this basis here for correction factor for vein shear testing in situ versus plasticity index. Vein shear testing on undisturbed sensitive clays being tested versus a parameter which is made after you completely remove. In other words, if we want to find out whether a carpet is really Persian or not, the smell of burning some of the wool, etc., is supposed to be a good indication. It's this destructive test. So you keep, first time you don't quite find it, you keep burning your carpet until it's gone, and then you decide that it was really a Persian carpet. Well, So, 10 minutes ago? Good. Thank you. So, here are some of the other fantastic things. And the basic point is that we should reanalyze the very concept of our plasticity limits. Before getting into that, I'm going to give you a little bit of my thoughts, constructive thoughts. Conclusions. Design predictive abilities to be tested on real professional problems. Do not get seduced by your internal enthusiasms and transform a real professional problem into something that's trying to develop a new theory and this and that and so on. Unfortunately, if you do that, you are really creating new conditions difficult to repeat. Truly repetitive challenges required for statistical conclusions. Now, nothing is ever repetitive, but sufficiently repetitive. You have a certain number of buildings that are essentially similar. You can. Now, one thing that my dear friend Bill Lamb did, I think, real harm to the profession in this new era of predictive versus performance challenges is his classification, not only of type A, type B, type C, type D, but also his demeaning mention that any prediction except the type A is bad. Presuming that all of us cannot disguise to ourselves. Well, I think the cheapest predictions that can be made is, let us go to the offices of the hundreds of different designers and executors, pick up their cases or buildings or foundations and so on that have been designed and monitored, and present that without anybody knowing. You can have a building from Sao Paulo transformed hypothetically into Bangkok, or from Bangkok hypothetically to Naples, and so on. You can repeatedly present the same building without anybody knowing that it is the same. All you have to do is pick up the column loads and revamp them, like a column of 500 tons here, put it there and so on, so nobody recognizes, and have the same case presented 1, 2, 3, 4, 5, 6, 10, 12 times, and check what is the dispersion, or even ourselves in face of the same problem that we don't know whether it was the same. So it's far better to use well-documented works, perfectly discussed, disguised, repeatedly pre-disguised. Can we disguise? Of course you can. Well, you ask if you want, just shuffle something random, okay, disguise, period. Now, we must separate knowledgeability from pressured decision. Knowledgeability is something very important as a start. But in our profession, in which each case is different, if you have first the very best of gladiators from the world to go and face a different type of lion or another bear or not, well, for heaven's sake, everybody is shy and afraid. You have to give him a problem that is a real everyday type problem. And finally, of course, I keep insisting on this term: revise, discard, renew, etc. The basic question with respect to how do we really want to grow in our ability to face some of these problems for the future. Now, to go back for a moment to the plasticity chart. Does it really give us any of the parameters we want? What are the parameters we want? Phi dash, SU, E, mu, and so on. Well, to begin with, it's nomographically and so on a bad choice to use only 45 degrees of a page when you really want to open the range for distinguishing. Classification means distinguishing. I see gentlemen here who have beautiful head of hair that I envy, and others who are more or less like myself, parabolically designed. So we distinguish. So if you clamp everything, there's nothing to distinguish. So that's his first mistake. Well, second mistake is that each one of these tests is very crude. But let's forget that, because everything was crude yesterday and obviously is going to be perfect tomorrow. But the fact is to use the crudest of the three, which is the difference between the two, by theory of errors, is absurd. So how about trying with real data, double regression, using liquid limit and plastic limit? Well, pick up all the data from Lamb and Whitman's 1969 set of a whole 25 or so cases, and liquid and plastic limits of all the different clay minerals and so on, and try a double regression. You get very poor results. R square 0.4, Galaxy, Orion, and so on. So let's be willing to have a renewed start. Why don't we? I mean, why did only people 60, 70 years ago have that liberty to invent whatever they wished, and we find ourselves stifled? Why? Now, fantastic, very easy, my very dear friend, Bishop and others, with very flat slopes, slices, vertical, and so on. And we go to steeper and steeper slopes and continue still with vertical slices, and sigma 1 being gamma z. Well, that is really absurd. So what should we do? Well, we can reanalyze stability by several important points. First point that I wanted to mention to you, I don't know if it went by here, the 10 minutes is pressing on in my conscience right now. Well, first thing that I wanted to mention to you is the following. One of the greatest errors introduced into soil mechanics by statics and determinism is that failure is equivalent to factor of safety 1.00. Bishop and Bjerrum, Boulder Conference, 1960, etc. Listen, as I say, my very dear friends, both of them, brilliant people. And it is inevitable that they were conditioned by the DNA of statics and determinism. But why the hell, pardon me, why on earth does a failure have to correspond exactly to 1.00? I've tried to insist on that for a long time. We don't calculate statics. We calculate destabilizations. If I assume a slope is initially relatively stable, it has a factor of safety, let's say 1.3, 1.4, and a cause-effect relationship, what changes? Flow net changes. Well, when the flow net changes, it changes delta Fs of some value. So if it goes from 1.3 minus 0.5, it goes through 1. And going through 1, presumably at the moment it goes through 1, there's an alarm clock and say, well, you're failing. Help yourself. Well, we really go through 1 to fail. We don't fail at 1. So that makes a tremendous difference with respect to analyses. So let's suppose construction period analysis for a dam. You start going up, you determine the final pseudo surface of siding and so on. But then let's see what happens if I stop here and increase gradually from 70% to 85% or to 100% this delta gamma, this delta overburden. Now, when I apply this delta overburden, is it valid that the entire, these are wedges, of course. I don't know how many of you have seen failures. They fail with all sorts of chunks in different directions. They don't fail like cheese cut in slivers that you had for breakfast. So the fact is that when I apply this, I have still a factor of safety quite big, 3 or 4 or 5, I hope, because otherwise I'd be in danger. Now, when I apply a load on top of an elastic body, does it come straight down only as a sigma 1 directly on that slice? Obviously not. It distributes by elastic medium or whatever it may be. So revamp all of this analysis, and so you find in completely different types of results. Well, I see that Mike Zamukovsky is just getting up, and I want still to mention on behalf of more than the three phases of typical sedimentary soils, the fact that, for instance, in saprolites and in many fills,